A group of scientists gathers at the La Jolla laboratory of the Institute of Geophysics, University of California. Their discussion concerns the results of a unique experiment. They have been studying the passage of waves across the Pacific, identifying and following groups of waves all the way from their source in Antarctic storms northward to the coast of Alaska. Dr. Walter Monk, director of the laboratory, originated this study of energy, waves, and the sea. With his colleagues, he spent an entire summer tracking waves generated by the severe Antarctic storms.
The sea itself was our laboratory. Ocean swell, trains of waves moving across the sea, can come halfway around the world to deliver its power on the shore in the form of breakers. And here in the surf, the historic line of battle between land and sea, that power is immediately clear. Here the energy of the waves seems concentrated. In the past, our data was visually recorded by wiggly lines on paper. For this expedition, the data would be recorded on punch tape equipment for direct input into a computer. I was frightened by the idea of using such fancy digital equipment on remote islands far from repair facilities. But I agreed it was necessary because of the large volume of data we anticipated collecting. The speed of the modern computer would allow us to get some results while the stations were in operation, to play things by ear, and to improve our procedure in the field. We lived in a Samoan folly on the edge of the village. The house was built entirely of coconut palm, an ideal place to work on waves. The house was open on all sides. It afforded lots of comfort and no privacy. To operate our recording equipment, we had taken along our own generator. As at all the stations, we recorded for 3 hours twice each day, from 4 to 7 a.m. and from 4 to 7 p.m. Each day we punched out 10,000 data points to be digested by the computer at home. We hardly ever missed a measurement. The equipment worked admirably, and my initial apprehension soon vanished. Data taking became quite routine. My wife and some of the Samoans learned to operate the recording equipment. When at the end of the summer we finally returned to California, we had amassed 10 million data points documenting waves from 12 major storms. A person with a desk calculator would have taken 2,000 years to convert this data into a meaningful picture of what happened. With a high-speed computer, our analysis was finished within a week of the end of the expedition. In talking things over, we're pleased with how well these storms were documented by the experimental program. We are somewhat disappointed that the measured attenuation varied considerably from storm to storm. But this should be no surprise, for in nature, no two storms or no two waves are ever alike.